Hello Math 20-1s. Today we're going to do a review of factoring. Alright, to do that we're going to have to remember what a simple trinomial is. We'll start nice and easy. So a simple trinomial is any trinomial that has the x squared term with a coefficient of 1. Before we do that, let's recall that if I expand two binomials, x plus 6 times x plus 4, I get x squared. Add 4x plus 6x is 10x. And 6 times 4 is plus 24. If we have a quick look at that, we notice that the middle term is the sum of the two constant terms of the binomial 6 and 4. We notice that the 24 is the product of the two constant terms 6 times 4 of our two binomials. How can we use that? This idea of sum product, that's what we're going to use to determine how to factor a simple trinomial. So if you're asked to factor a simple trinomial like x squared plus 9x plus 20, it's got a 1 in front of our x squared term. Therefore, it's a simple trinomial. We ask ourselves, what two numbers have a sum of the middle term 9 and a product of the last term 20? Keep in mind that expanding out two binomials will give us a trinomial. We're going to factor this as two numbers that multiply to 20 add to 9 are 5 and 4. So the factors would be x plus 5 times x plus 4. Let's try another one. Again, what two numbers have a sum of 13, a product of 36? Because it's a simple trinomial, we can use sum product. Those two numbers are positive 9 and positive 4. So remembering that we have to multiply two binomials to get that trinomial, we're going to have x plus 9 times x plus 4 as the factors of x squared plus 13x plus 36. Looking at a third one, same procedure. What two numbers add to negative 11, multiply to 24? If you came up with the numbers negative 8 and negative 3, you are correct. Then the factors would be x minus 8 and x minus 3. And let's look at one more. X squared plus x minus 20. This has a sum of the middle term, which is 1x, and a product of the last term, which is negative 20. So what two numbers add to 1, multiply to negative 20? Write them as two binomials with an x in the front of each. So those two numbers should be x plus 5 times x minus 4. Excellent. Next we'll look at factoring a difference of squares. Again, recall that if we multiply two binomials that are called conjugate binomials, the product is a difference of squares. So conjugate binomials are almost exactly the same binomials except for the sign in between them. If I expand out these two conjugate binomials, I get x times x, which is x squared. I get x times 7, which is positive 7x, and negative 7 times x, which is negative 7x, and those two terms will cancel out to 0. And we've got negative 7 times positive 7 giving us negative 49. So x squared minus 49 is called a difference of squares. X minus 7 times x plus 7 are called conjugate binomials. Therefore, if we're going to factor a difference of squares, the factors will be conjugate binomials. So going the other direction, from x squared minus 49 as two factors, we get conjugate binomials x minus 7, x plus 7. So if you're asked to factor x squared minus 81, the trick is to figure out what the square root of the first term is and the square root of the last term. So the square root of x squared is x, the square root of 81 is 9. Or we could write it as x all squared minus 9 all squared. If we do that, then it's easy to figure out what our conjugate binomials are. So we're going to have an x in the front of each bracket, we're going to have a 9 in the back of each bracket, and make them conjugates by having opposite signs. So the factors of x squared minus 81 should be x plus 9 and x minus 9. If we look at something like 16x squared minus 121, again we're looking for the square root of the first term and the square root of the second term. So we could write this as 4x all squared and 11 all squared. If we rewrite it like this, then it's easy to figure out what the conjugate binomials are as factors. So the square root of 16x squared is 4x, the square root of 121 is 11, So our factor should be 4x minus 11 times 4x plus 11 as conjugate binomials. All right. We look at a third one, 5x squared minus 80. I look at something like this, and I notice that 5x squared doesn't have a perfect square root, and neither does 80. So I must recall here is how to common factor. I notice both these terms have a common factor of 5. So that should be my first step in this case. Take out a common factor of 5. So I divide both terms by 5, and I get 5 times x squared minus 16. Now I look inside the bracket, and I notice that this is a difference of squares. So I look for the square root of x squared, which is x, the square root of 16, which is 4, and I can factor the inside of the bracket as a difference of squares with conjugate binomials. Don't forget to keep your 5 out front. So the factors would be 5 times x minus 4 times x plus 4. Very nice. Simple difference of squares. And we did simple trinomials, and that's all we're going to do for the first part of this lesson. 3.1a. You guys can work on page 177, numbers 1 through 6 in class tomorrow. See you then.